welcome to BSS Studies. I am Bala. Today our new topic from physics, dynamics. Today our new topic from physics, dynamics. So we are already learned kinematics. What is kinematics? Kinematics means the motion of an object without consideration of force. In kinematics, motion of an object without consideration of force. In kinematics, force will not there. We should not consider force. In kinematics, we should not consider force. In dynamics, we should consider force. In kinematics, we should not consider force. In dynamics, we have to consider force. For example, in kinematics, I am taking equation V is equals to U plus AT. This is first equation of motion. In this equation, there is no force. Here you will get doubt. What is force? Force means F is equals to mass into acceleration. Force is equals to mass into acceleration. Here there is no force. Force means mass into acceleration. Here there is no mass into acceleration. So we should not consider force because a car is traveling. There is no force is applying. Okay? So here dynamics means motion of an object with consideration of force, and here kinematics means the motion of an object without consideration of force. Okay? So here kinematics, dynamics, these are branches of mechanics. Here dynamics, kinematics are branches of mechanics. So here you will get doubt. What is mechanics? We already learned what is physics. Physics means study of nature and its laws. Study of nature and its laws. So here in physics, it is the first branch, mechanics. This is first branch. And there are so many branches: acoustics, thermodynamics, optics, nuclear physics, modern physics, etc. So this is one of the branch. This mechanics is defined as motion of an object. Motion of an object. This mechanics is defined as motion of an object. Okay? So here mechanics is again divided into three branches. Mechanics is divided into three branches. Here first kinematics. Here first branch kinematics and second branch dynamics, third branch statics. Okay? Here mechanics is again divided into three branches. First one kinematics, second one dynamics, third one statics. So here we already learned kinematics, motion of an object without consideration of force, and simply force will not there. And kinematics is again divided into two branches. Kinematics is again divided into two branches. In that, motion in a straight line, and motion in a plane. This kinematics is again divided into two branches: motion in a straight line and motion in a plane. We have to learn motion in a straight line only. In higher classes, you will study motion in a plane. So in dynamics, force will present because dynamics means motion of an object with consideration of force. This is with motion of an object with consideration of force. We have to consider some force like gravity, frictional force, gravitational force, weight, etc. Okay? So in dynamics, we have to mention straight line. In dynamics, motion in a straight line only. Okay? We have to mention straight line and uniform acceleration. Like kinematics in motion in a straight line. We already learned motion in a straight line means path is straight and uniform acceleration. In this dynamics, we should mention straight line and uniform acceleration. Okay? So statics. Statics means rest position. Rest position. Rest. There is no motion. Only rest. Okay? So these are the branches of mechanics. Here mechanics is divided into 3 parts, 3 branches: kinematics, dynamics, statics. And kinematics is again divided into 2 branches: motion in a straight line, motion in a plane. Okay? In dynamics, we have to consider force and straight line and uniform acceleration. Uniform acceleration. Okay? Here, dynamics. In dynamics, we have to discuss mainly Newton's laws of motion. Newton's laws of motion. In dynamics, we have to discuss mainly Newton's laws of motion. Here simply NLM. Newton's laws of motion. NLM. Okay? In this Newton's laws of motion, there are 3 laws. 3 laws. In Newton's laws of motion, there are 3 laws. In this video, I will explain first law. Okay? Newton's first law. Here, Newton's first law defines every object states to rest or uniform motion until any external force is applied. Here, Newton's first law defines that every object states to rest, continue rest, or uniform motion until any external force is applied. Okay? So here, object states that it continues rest and it continues uniform motion and uniform rest until any external force is applied. If any object continues rest or continues uniform motion any external force is not applied, if any external force is applied, this rest and uniform motion will not there. If a car is traveling 80 km per hour uniformly, I am applied some force to stop. So there is a force applied to become rest position. Here this Newton's first law states that every object states to continue rest or continue uniform motion until any external force is applied. If any external force is applied, if uniform car is there, it will become rest. If any external force is not applied, it will go with 80 km per hour. Okay? So this is the first law. It is very important statement. Every object states to rest, to continue rest or continue uniform motion until any external force is applied. If there is no external force, the uniform motion or any rest object will continue in rest and uniform motion. If any external force is applied, this become rest and this become motion. Okay? In Newton's first law, this law defines inertia, mass, force, mechanical equilibrium. Here, Newton's first law defines inertia, force, mechanical equilibrium. We have to learn inertia and force and this mechanical equilibrium in higher classes. Okay? So here, if we see inertia, first force. Here, Newton's first law defines inertia, force, mechanical equilibrium. In force, if we take force means a push or pull. If I push 10 kg rice bag, it displaces some distance. If I push, so that is called force. Force means 10 kg rice bag and it displaces some distance with v velocity or speed. That is called force. Push or pull. We have to push a wheelbarrow or a pull wheelbarrow, etc. So here force also changes state and changes velocity, changes acceleration, etc. Because push or pull, we have to push or pull, then only changes from rest to uniform or uniform to rest, or changes velocity or changes acceleration. When force is not applied, these are not changes. These are not change. Okay? When force is applied, push or pull, then only these state, velocity, acceleration are changed. Okay? So this is the force, and the mathematical formula of force I will explain in Newton's second law. Mathematical mathematical formula. F is equals to ma. I told in first. F is equals to ma. This mathematical formula derivation in Newton's second law. Okay. Only definition of force in first law and derivation of mathematical formula in second law. Okay. So in Newton's first law, inertia. Here inertia means inability property of changing any state. Inability property of changing state. Inability property of changing state. If I am in rest position, if some force is applied to me, I will go in motion. Okay. If any force comes towards me, I will travel some distance, some displacement like this. Then only inertia applies. If for example some mass 4 kg and 4 inertia. 4 kg mass is there and 4 newtons we have to apply. That is the inertia. Okay. In inertia there is inertia of rest. Inertia of rest, inertia of motion, inertia of direction. Here inertia of rest, inertia of motion, inertia of direction. Inertia of rest means from rest to motion. If any external force is applied, the rest of an object will transfer uniform motion. Okay. If any external force is applied, then object which at rest goes to motion. Okay. If any external force is applied, the motion of an object transfer to rest. Okay. Here inertia of direction. If a car is moving in a straight line, if handle is circled to like this, it travel in this direction because wheels go in that direction. Okay. That is the inertia of direction, because in that we have to apply some force only. We have to apply force, then only it changes to rest to motion, motion to rest, straight line to any other path. Okay. These are the inertia. Inertia and inertia of rest, inertia of motion, inertia of direction. Okay. In this main important point is mass is the measure of inertia. Measure of inertia. Here, more the mass, more the inertia, because these are directly proportional. If more the mass, more the inertia. Less the mass, less the inertia. More the mass, more the inertia. Less the mass, less the inertia. Okay. Mass is the measure of inertia. This is very important point. If more the mass, more the inertia. Less the mass, less the inertia. Okay. If I am taking 4 kg rest bag, 4 newtons we have to apply. Okay. 4 newtons inertia. Okay. This is the Newton's first law. మీకు ఈ వీడియో నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి.